In section 4.1, we want to talk about graphing the basic sine function. And the equation for our basic sine function is y is equal to sine x. Here in my little t-chart, I have the x values, and the x values that we're going to use as input into our function will be the angles in radian measured. The y values will be the output once we find the sine of those angles. So we're going to take our equation, and we're going to solve for y. So the x value here is 0. Sine of 0, if we remember that the sine value of the angle is the second coordinate, so the sine value of 0 would be 0. The sine value of pi over 2 would be 1. The sine value of pi would be 0. The sine value of 3 pi over 2 would be minus 1. And back to 2 pi, our sine value would be 0. If I keep going, we're going to go another pi over 2, so that would be 5 pi over 2 would be here. That gives us a sine value of 1. 3 pi would be here, and that would give us 0. 7 pi over 2, coterminal to 3 pi over 2, would be negative 1, and the sine value back at 4 pi would be 0. We start to see that the sine values repeat themselves between 0 and 2 pi. Every 2 pi units, the values start to repeat. So we want to graph our sine function. And remember that our x values are angles and radians. And remember, radians are basically the same thing as just real numbers. So we're graphing on our real number line. Our y values are the sine values of those angles. At 0, we got 0. At pi over 2, the y value is 1. At pi, the y value was 0. 3 pi over 2, we were down to minus 1. And then 2 pi, we were back at 0. This is what we would call the basic shape of our sine function. Our sine function, our sine wave, continues forever in both directions using the same pattern. So from 0 to 2 pi, we're going to call this the basic shape of sine. Notice that it starts at the axis on the x-intercept of 0, and then reaches a max, comes back down to the x-axis, reaches a min, and then comes back up to the x-axis. The distance required to complete one full cycle is called the period, and the basic shape of our sine function has period 2 pi, meaning we complete one cycle in 2 pi units. As we graph, we want to know the basic shape of sine from 0 to 2 pi, so we're going to remind ourselves of what that looks like. It starts at the x-axis at 0, and then at pi over 2 we reach a maximum. At pi we come back down to the x-axis. At 3 pi over 2 we reach our minimum, and then at 2 pi we come back to the x-axis. So we want to make sure that we know this basic shape of sine. Now keep in mind that it does continue forever in both directions, but we want to keep track of this basic pattern. X-intercept max, x-intercept min, and then back to the x-intercept. So y equals sine x has a domain of negative infinity, positive infinity. What that means is that we use all of the x values as input on our number line. The range goes from minus 1 to 1. The period is 2 pi, and the amplitude is 1. When we talk about the amplitude, we mean the distance from the middle of the graph to the top and from the middle of the graph to the bottom. The amplitude is always considered to be a positive number because it's talking about a distance. The graph is symmetric with respect to the origin so that the function is odd. And by definition of an odd function, what we mean is that the negative on the inside for the input basically comes outside and becomes the same thing as a negative on the outside of our function. In practical terms, that means that the sign of negative pi over 2 would be exactly the same thing as minus the sign of positive pi over 2. So these sign values would be exactly the same. And in fact, sign of negative pi over 2 would be minus 1. The sign of pi over 2 is positive 1, but then the negative comes on down. So we see that they would be equal. We also notice that if we look at our graph is separated into 4 equal segments. Each one of these represents one quadrant, or pi over 2, or 90 degrees. This represents quadrant 1 from 0 to pi over 2. This represents the sign values in quadrant 2. Notice that sign is positive in quadrants 1 and quadrants 2. In this section from pi to 3 pi over 2, this represents quadrant 3. And from 3 pi over 2 to 2 pi, we have basically sign values represented from quadrant 4. And notice that in quadrants 3 and quadrants 4, sign is negative.